Alright, the first couple methods that we've learned for helping us to solve a quadratic equation work some of the time, but not all of the time. There's certain things that don't quite factor very nicely, or times where taking square roots isn't convenient. The next two that we're going to look at, which are completing the square and the quadratic formula, are things that work all the time. So our goal here is to create what we call a perfect square trinomial, so that the left side condenses down to something that's squared and the right side is a constant, and you can use the formula or the application of extracting a root. So starting with ax squared plus bx plus c, you want to get everything equal to 0, divide everything through by the leading coefficient, isolate the terms with x's, which means move the constant to the other side, take half of b and square it, add it to both sides, rewrite the left side as the perfect square trinomial, again some binomial that's squared, and then solve by taking the square root. These steps look a little more complicated than I think they actually are, so let's go ahead and just jump right into an example so you can see how it works. So, first of all, everything is set equal to 0. There's no greatest common factor that we can pull out, all of that stuff. We're looking to complete the square. So, steps to completing the square. Step 1 is divide everything through by the leading coefficient. Well, in this case, our leading coefficient is 1, so we don't have anything to divide by. Step 2 is to isolate any terms that have x's with them on one side and get your constant to the other. Now, some teachers have students write this in. I think it helps to remember that whatever you add on the left side, you're going to have to add on the right side to keep the equation balanced. So then step 3 says add half of b, or b over 2, and square it. Well, here's b. So b over 2 squared is really negative 1 squared, which is 1. So we're going to add 1 and add 1. Step 4 says write as a perfect square trinomial. So this part right here, if you go back and you try to factor it, you're going to notice that this ends up being x minus 1 squared. Because this number right here, before you squared it, is what goes in this location in the binomial. And then this is all equal to 6. Now we can extract our square root. So take the square root of both sides. X minus 1 will be equal to plus or minus 6. Sorry, root 6. Root 6 isn't going to simplify, so we just get x equals 1 plus or minus root 6. Now, looking at this, it would have been really hard to try to figure out factors using radicals and your irrational roots. It just becomes really messy. So completing the square is a method that always works because there is no way to factor this in the way that we have practiced factoring before. Alright, so next one, completing the square. Step 1 is to divide everything through by our leading coefficient. In this case, that's a 3. So I'm going to divide this whole side by 3, this all by 3. So 3 over 3 leaves me with x squared plus 8x plus 14 is equal to 0. Then we're going to get rid of our constant by moving it to the other side. Alright, this is the part then where we are actually completing the square. So we're going to take our b value, divide it in half, so 8 over 2 squared, which is really 4 squared, which is 16. So 16 goes here and here. This number is what goes into our binomial squared. Okay, so this 4 is a positive 4, which is why I kept the plus sign, equals negative 14 plus 16 is 2. Take a square root, since we have perfect squares on both sides. X plus 4 equals plus or minus root 2. X equals negative 4 plus or minus the square root of 2. Final answer. Alright, we're going to do 2 more examples. These next 2 start to involve a little bit of fraction work, because sometimes when you divide out by your leading coefficient, you get some fractions that you have to square, but we're going to practice them. It'll be alright. So my leading coefficient is 9. Let's divide through by that. So I'm left with x squared minus 12 over 9 is the same thing as 4 over 3. And 14 over 9 is not going to simplify. Alright, so then I want to isolate everything that has x's with it. Set up those spaces. I'm going to add 14 ninths to the other side. So this is where the fraction work gets a little bit messier. So we need to take negative 4/3, take half of it, and square it. Well, taking half of this would be the same thing as multiplying by 1/2. So really this is like having negative 4/6 squared, which is negative 2/3 squared, which is 4/9. So fraction work. 4/9 is what goes on both sides. Okay. Now we want to use this number, right? The one right before we squared it. That becomes our term in our binomial. 14/9 and 4/9 have a common denominator, so that's going to be 18/9, which is really just 2. Taking a square root of both sides, we get x minus 2/3 equals plus or minus root 2. So then x equals 2/3 plus or minus root 2. You'll notice that I write the constant in front of the radical, just as a way, I mean, it's just a notation thing, so you always have this number plus or minus whatever your radical was. Alright, next one, getting a little bit messier with fractions still. Solve by completing the square. Everything's set equal to 0. We're going to go ahead and divide through by that leading coefficient, so divide everything by 3. At the same time, I'm going to move my 10 to the other side. Okay? Next step is to take half of b and square it. So half of b would be 3/2. Squared is going to make 9/4. So 9/4 is what gets added. On this left side, remember this is the number right before you square it. That creates that perfect square trinomial. You could, if you want to, ask yourself what multiplies to 9/4 and adds to 3 and do all of that work. But this right here, if you just remember it's the number right before you square it, that'll make things easier. Here we're going to need a common denominator. So I've got 10 over 3 plus 9 over 4. Just do some side work. My common denominator of 12. So I'm going to get 40 twelfths plus 27 twelfths is going to give me 67 twelfths, which unfortunately does not simplify. Alright, so now I'm ready for my square root. Remember, when you take the square root of a fraction, you want to take the square root of the top and the square root of the bottom. Well, the square root of the top doesn't simplify at all. So we're just going to leave that as the square root of 67. But the bottom factors into 4 times 3. So you can take out that perfect square. And you're left with 2 rad 3. Last thing then is to get our 3/2 to the other side. Alright, now, you could leave your answer like this. Your calculator would understand what that answer means, but for mathematical notation, you might remember that we are not supposed to have square roots in the denominator, so we need to rationalize just this fraction. So I'm going to multiply the top and the bottom by the square root of 3, because that's the radical I'm trying to get rid of. So now I have that x equals negative 3/2 plus or minus the square root. 67 times 3 is going to be 201. 2 times root 3 is really just 2 times 3, which is 6. This you can leave as your final answer because you no longer have a radical in the denominator. Okay, so completing the square, again, the steps are not that bad. The fractions just get a little bit messy, but take your time. Make sure you find common denominators when you need to. When you square a fraction, remember you square the top and the bottom. Likewise, when you take a square root of a fraction, you have to take the square root of the numerator and the square root of the denominator. Alright, so this last one is just something I want you to question, and maybe take a minute to see if you can complete the square without any numbers. So just with ax squared plus bx plus c equals 0. Try to work on that tonight, or maybe tomorrow in class on a piece of paper, see what you can come up with. That's going to be our lead-in to our next unit, but it might help you to try to think about it ahead of time. So see if you can do everything just with letters and not with numbers.